So we can run the emission. And as it runs, you will notice that the shape of the beam is changing this time. If we watch the current, as Lorentz solves the model, you will see that again it is converging, oscillating very much at the beginning steps and less so as it continues. So at the beginning, the current is far overestimated, being a magnitude almost 400. The amount of space charge, again, like the previous problem, is far too much, and that causes an undercompensation on the next iteration. However, the oscillations become smaller and smaller, and at the end, we arrive at 103.26 amps, just like we did with the rectangular model. If we look at the shape of the beam, we can also see that the shape is converging along with the current. In the very first iteration, the beam is bending inwards because there isn't the space charge to push it out. The shaping of the electrodes creates a focusing of the field, pushing the beams in because the electrodes are producing a field as if there was space charge in that region. With the overcompensation of the charge deposited on the first step, that leads to too much bending of the field on the next iteration. Therefore, the rays are now pointing outwards and the beam is defocusing. As we progress towards the final current value, you will see that the beam becomes straighter and straighter, so that at the end we have obtained the expected value of 103 amps, and we have also arrived at the perfectly rectangular beam that we would expect.